Part of our lesson for section 2.7. Last time we looked at two theorems, Theorem 2.4 and Theorem 2.5. That was congruent supplements theorem and congruent complements theorem. That was our second and third theorem of this section. We're going to get to our fourth theorem at some point. We'll actually talk about it in this video. Okay, so if we go back to the congruent supplements theorem for a second, notice that underlined portion where it says or congruent angles. This is that case. So notice how you have two angles, A and B, that are supplements of each other, and you have two angles, C and D, that are supplements of each other. You can't use the congruent supplements theorem the way we proved it, because all of these angles are different, A, B, C, and D. There was no shared angle. Well, they also tell you what happens if angle B is congruent to angle D. If these two angles are different, but they're congruent, the congruent supplements theorem works also. Okay, now we should prove this, but I'm just going to kind of make you believe that it's true. So for example, I'm going to say that angle B is, I don't know, we'll just make it easy. I'm going to say it's 80 degrees. Well, if it's congruent to angle D, then it's also 80 degrees. And if both of these angles are 80, what does that do to their supplements? The supplement of 80 is 100. That's angle A and angle C. They're both 100. Well, if you know all of this, what do you know about angle A and angle C? They're definitely congruent to each other. Okay, now I just proved that it works when angle B is 80. Well, it works for all cases too. That's why you would prove it, so you could see that it works for all cases. Okay, but that's what that means there. That's the or congruent angles portion. Here's another postulate. We've already gone over 11 postulates. This is number 12. It's called the linear pair postulate. And this is really, really valuable when you notice that there's a linear pair in a diagram. If you notice there's a linear pair, then what that means is those angles are supplementary. Okay, so here's some specifics about this diagram. Angle 1 and angle 2 form a linear pair. We can notice that. Remember, that's one of the things we're allowed to assume. So what that means is angle 1 and angle 2 are supplementary, and their measures add up to 180. So instead of saying in a proof, hey, these are a linear pair, next step, that means they're supplementary. Next step, that means their measures add up to 180. That's 3 steps that you don't need if you use this postulate. If you use this postulate, it kind of cuts those 3 steps out. Okay, so we will use this very, very soon. Here's your last theorem, and you're going to use this a ton this year. This is Theorem 2.6. It's the fourth theorem that we've looked at in this section. It's called the vertical angle theorem. Here's a diagram. Hopefully you remember which angles are vertical. The vertical ones are the ones that are across from each other when two lines cross. So angle 1 and angle 3 are vertical. Angle 2 and angle 4, they're vertical also. Now, I'm pretty sure you already know what this theorem says, because we've used the relationship with vertical angles many times before. Vertical angles are congruent. That's what the theorem says. So that means this angle and this angle, since they're vertical, they're congruent. You can put those arcs there. Also, angle 2 is congruent to angle 4. Now, notice how I used matching arcs for angle 2 and angle 4, but I used different arcs than I used for 1 and 3. That's because angle 1 and angle 2 aren't necessarily the same. Remember, angle 1 and angle 2 are a linear pair. Okay, so vertical angles are congruent. And remember, we figured that out. We kind of proved that that was true, or we at least believed it back in chapter 1. Again, I'll just make it simple. Let's say angle 1 is 80 degrees. Well, if it's 80, you know that angle 2 is its supplement, because notice how angle 1 and angle 2 make a linear pair. Okay, so if you're using that linear pair postulate, you know the angles add up to 180. So angle 2 is 100 degrees. Angle 2 and angle 3 also make a linear pair, so you can use that linear pair postulate again. So angle 3 is 80 degrees, because they're supplements. And then same thing here. That makes this guy 100. What do you notice about angle 1 and angle 3? They're congruent. What do you notice about angle 2 and angle 4? They're congruent as well. So that's your vertical angle theorem. We kind of walked through this particular case, so now you know it's true. In the next video, we'll prove that it's true.